So here's one last example. It looks just like the other one, but it's slightly different. So that's why I'm doing here. So the first thing we've been doing is this computing the standard form. But look, here the numerator is degree is 1 and denominator degree here is 2. So already the numerator is a smaller degree than the denominator. I think I didn't explain sufficiently in the earlier videos that if you have a polynomial of this type, this will approach 0 as x approaches positive infinity or negative infinity. So if the degree of the denominator is bigger, for large x value or x with the negative value with large magnitude, and this will go to infinity really quickly. Whether it's positive or negative infinity, it doesn't matter. The size dominates, therefore this will approach 0. So we have something to say already about this shape. But again, the point is that we don't have to do the long division. It's already smaller numerator in terms of degree. So let's do the similar thing we did. So I'm going to rewrite this one so that it looks a lot like what we were doing before. All right, I decided to hide it. So I inserted this 0 there so that you can easily see it into this form. So this is going to be the vertical, keep mixing this up, horizontal asymptotes, because as x approaches positive infinity, negative infinity, because of this small degree thing, this is going to approach 0, and that's the number that what the function value is approaching. So if this were 5, this would have had larger degree than 1, so we'll have some number. But this time it's 0. So look at this. As x approaches positive infinity, because it's even degree in the denominator, that's going to be approaching positive infinity. So positive there. Positive infinity odd, but it's a positive infinity. It's an odd degree. So that approaches positive infinity. Altogether, this quantity right here is approaching positive quantity, but it's almost 0, so it remains slightly greater than 0, 0 plus this positive number. So we use this notation 0 plus. If you look at x equals negative infinity this time, then you look at here, the denominator is degree 2, so it's still approaching positive infinity. That's the end behavior of even degree polynomial. If you look at the numerator, it was odd again, x to the first. Therefore, this time as x approaches negative infinity, is approaching negative infinity. But this one is going to the infinity faster overall because of the degree difference. This approaches 0, but remains as a negative number. So 0 plus negative number is slightly less than 0. That's why you see 0 superscript negative. So this guy is approaching to the right, approaching from above. To the left, it's approaching from below. And the horizontal asymptote is, this is 0, y equals 0. For the vertical asymptotes, this is part for the vertical asymptote, we need to factor the denominator. The vertical asymptote is coming from the denominator here. So that's why we factored it. When you factor this one, it turns out it's the multiple linear factors there. So it's x plus 5 squared. So we only see one vertical asymptotes here. So let's repeat what we did to figure out the behavior around the vertical asymptotes. So vertical asymptote is x equals negative 5. Behavior, we were using this notation, x is very close to negative 5. And we didn't touch that, the factor that's responsible for that behavior, but everything else, which is 5x plus 21, we actually plug in x equals negative 5. And so that predicts a correct behavior for other terms, especially the sign. So this number turns out it's negative 4, negative 25, and 21. So it's negative 4. So we picked up negative number. So that tells us there's a denominator square and negative constants outside. So that's not exactly equal, but that's the rough behavior of the y value when x is very close to negative 5. It behaves like this. So if you look around, x equals negative 5 because of negative 4, and even degree together forces it to behave like this. Now let's compute the x-intercept and y-intercept so that when you put this vertical asymptotes and horizontal asymptotes together, when we cross x-axis and y-axis, it gives an idea to how to draw it more accurately. So x-intercept is 1 when y equals 0. So this form, this one rational form here, is convenient to compute this x-intercept, because if you set this one equal to 0, only the numerator has to be 0 and denominator has to be non-zero. So first we'll find this number, which is negative 21 over 5. Then make sure that it is not 0 in the denominator, but usually they give you this quotient in the lowest term, so this will be sufficient thing to check. Y-intercept is relatively easier. This is when x equals 0. So like this, and x equals 0. So when x equals 0, it only picks up 21 in the numerator and 25 in the denominator. So we have this number. This is fairly close to 1, and this is fairly close to negative 4. So we're going to use that to put these together. So I'm kind of blocked some of the views. This is supposed to be where x equals negative 5, just like that part. I better write that down. Okay, I wrote in here, x equals negative 5, and it is the behavior that was noted earlier around x equals negative 5, they're both going down. I'm showing a little bit of a glimpse of this number, which was one of the x-intercept here. There's only one x-intercept, negative, a little bit more than negative 4. So that's this is the origin, and that's the 5 unit. So it's very, very close to this vertical asymptote when it hits here. So that's the behavior. Right, I'm hiding the remaining part to focus on the horizontal asymptote. That was 0. If you go back, and it says it's coming from above as you go to the right, infinity. When you approach to negative infinity here, is coming from below. So that must be the behavior. So here, y-intercept and x-intercept should put together. So another thing is that we should come from above, and around x equals negative 5 here, you can see both of them going down. So here are the bits and pieces. I put those both going down to negative infinity around x equals negative 5 sketched here, and then think about we're having x-intercept there, right? It crosses, and then we're going to have y-intercept there. Then kind of this is y-intercept, it crosses. That's a reasonable picture, and think about what's going to happen to this portion right here that evidently had, because it's a positive part here, evidently had to turn around and approaching from above. That's the simplest picture you get. So you have to think about it a little bit and to come up with the simplest reasonable picture, and by practicing more of this type of problem, I think following answers are quite reasonable. Here's what I got. Of course, again, these are just using behavior around the vertical asymptotes and horizontal asymptotes here, using some of the x-intercepts and leaving out what's really happening in between here and there. But this seems like a reasonable guess if you don't further investigate, and more of this ups and downs is studied in calculus, but this is what we can get right now. So it's more geared toward to analyzing how do you put together with this behavior we figured it out with additional information. Okay, thanks.